Today I will give you a short method that how to find the relative density for given substance by using an easy method. I think you know about what is the meaning of density. The density for a given matter is taken by the ratio between mass and volume. That means if you are taking the mass of a unit volume, then it becomes the density. But think about relative density. We are taking it by the ratio between two densities. One density is a standard value. That one is taken as the density of water. Normally, we have to divide density by density of water. For density, we take it as rho. Rho become m divided by v, unit sum, kilograms per cubic meter. But here, relative density become unitless. Normally we consider it as rho r equals rho divided by rho w. Here rho w become the standard or the reference density. Normally we consider it as 1000 kilograms per cubic meter. But don't forget that practically if we measure the density of water at the laboratory, normally we are having a value lower than 1000 kilograms per cubic meter under practical condition. Because we know that actually the room temperature is nearly around 27 degrees Celsius, and so that the effective density for water will change due to expansion of water. And this value, that means 1000 kilograms per cubic meter, is actually taken at 4 degrees Celsius. This one is the maximum value for the density of water. And so that when water expands, density reduces. That's why we are having a lower value than 1000 kilograms per cubic meter at normal room temperature. So that this value is taken at 4 degrees Celsius. Right. Now so that this relative density can be taken by rho divided by rho w. And normally we take it as the specific gravity also. Think about specific gravity for mercury, it becomes 13.6. Right. Now here my main target is to give an instant method to find the relative density for a given substance. Right. Now here I will sketch several small diagrams to explain that how I can take that simple method to find the density. Now here think about a mass 200 kilograms. Think about its volume as 2 cubic meters. And clearly you know that simply you can take the density by dividing the mass by its volume. So that you will have it as 100 kilograms per cubic meter. This one is the density. This one is very simple. Now here I am giving a such method to find the relative density instantly. Now think that an object floats freely in water as half of its total volume immersing in water. That means the fraction in water become half from the volume of the object. So that since the fraction become half, I need to find rho divided by rho W. Rho is the density of this substance and rho W become the density of water. That means I am taking the relative density of this object. Now here, since the fraction become half, you will have the relative density as half. And think another one. Sometimes you may think that this one is very easy. Actually, this one is very easy. But here, I need to give a secret method in the next part. Now here, think that this block floats freely in water as 3/4 from its total volume is immersing in water. Then rho divided by rho W, that means relative density or specific gravity become 3 divided by 4. Again think that this object floats freely in water as 2/3 of its total volume is immersing in water. Then again rho divided by rho W become 2 divided by 3. Now here clearly you have taken the relation by using this pattern, right? That means by the fraction directly you are able to take the relative density or the specific gravity of this substance that the object has been formed. Now this one is not my method. Now think a case that a uniform rod floats in a container filled by water as one end is touched on its vertical wall. As an example, think about this container. Now here partially water has been filled, and think that half of this uniform rod, that means if the fraction become half, is in water. Now here I need to take rho divided by rho W. How that I can find rho divided by rho W? By using 2 seconds. Only I need 2 seconds. Sometimes you will tell that this one become half. No, that one is incorrect. Here you can see that one end has a support by the vertical wall of this vessel, and so that we are not having this one as half. If this one floats freely as half of its total volume immersing in water, then clearly it becomes half. But here the specific gravity doesn't become half. But I can take that one instantly. It becomes 1 divided by 4. The next one, look at this one is next example. This one is my container, and here think that 3/4 of the rod is in water while this bottom end is in contact with the vertical wall of the container. This one is 3 divided by 4. The fraction becomes 3 divided by 4, and so that rho divided by rho W, that means relative density for this rod become 9 divided by 16. I will give another one. Look at here. This one is the container partially filled with water, and here think about that 2/3 of the total length of the rod immersing in water, and you can see that again here this end has been touched, and here rho divided by rho W become 4 divided by 9. Now look at these fractions. Here relative density become half. The fraction in water become half. The fraction here in water become 3 divided by 4, and we are having relative density as 3 divided by 4. And here the fraction become 2 divided by 3, relative density become 2 divided by 3. But here you can see that you have to take the square of the terms. Here the term become 1 over 2, and if you are taking the square, it become 1 over 4. Here the term become 3 divided by 4, the relative density become 9 divided by 16. Here the ratio become 2 divided by 3, and here the relative density become 4 divided by 9. Only you have to take the square of this value and you will take the relative density. This one is very easy. If you are giving a rod and you are telling that 3/5 from the total volume is immersing in the water while one end is touched on the vertical wall like this, then you can take the square of 3 divided by 5 and you will take the answer as 9 divided by 25. A very simple method. Now sometimes you may think that how that we can take these relations. Now here I will explain the method that we can take to demonstrate this one. I am using some basic theories. You know about the principle of floating and also Archimedes principle. I am using them and clearly I will explain that how I am having such relations. Now you can remember these values. You have noticed them. Now here first I am taking the object floats freely in water. We know that density for water I am taking it as rho W, and the density for the substance I am taking it as rho. Simply we know that according to the principle of floating, the upthrust exerts on the body become equal to its weight. That means if I consider vertical forces, then U become equal to mg according to the principle of floating. Now by using Archimedes principle I can write the upthrust U as V rho Wg. Here V become the immersion volume of this object in water, and so that I am taking it as V rho Wg equals mg. Now think about the mass of the object and the immersion volume. Here, think that the immersion volume for the object become half from its total volume. That means if this volume become V, then the total volume of this object become 2V. Here the fraction become half in water, and so that V rho Wg equals, now I need a mass. I need the mass of this object. Mass become density into volume. Volume become 2V. Now here you can cancel simple G and also V. Clearly you will take rho divided by rho W as half. I gave this ratio previously. I told that to notice that one, Putya, right? Okay, now here you know about how to take the relative density by using a very small calculation under the principle of floating, and so that here clearly the fraction become half, and so that the relative density become also half. Now the next one, this one is a very important part of the theory today. I will explain that one here. Clearly I think you have taken the idea of this solution, and I am using that this one because I need to explain the next one. Now think about the rod. Now here, one end of the rod is touching on the vertical wall of the container, and think that I am taking the total length of this rod as capital L, and also I am taking the length of the path in what as simple L. Now think about the forces exerts on this rod. The first force is the weight of the rod. I am taking it as mg. And the next one, the upthrust. The upthrust is exerting at the center of buoyancy. That means actually, since this one become a uniform rod, it exerts at the middle of the immersion part of the rod. That means if I am taking this part in water and I have to take the center of this part, that means nearly at here. This one is the upthrust. And also don't forget to apply reactions at this end, because this end is touched on the vertical wall of the container. And so that I am applying two reactions here. A vertical reaction I am taking it as y, and horizontal one I am taking it as x. Actually x and y become normal reaction and the frictional force respectively. If you like to apply the vertical force towards downward direction, then you can apply it. That one is not a problem, because here actually I am solving this one to find the relative density of the substance for this rod by using moments around this point. That means if I am taking the rod as AB, I consider moments around capital A, and that's why here x and y forces become cancelled. Now here I am taking the moments counterclockwise, and so that think about the upthrust u. I need the perpendicular distance between point A and the line of the upthrust u here. Here think about this small length. This small length become L divided by 2. You have to be careful to find the distance accurately, and here this one become L divided by 2. I am taking the horizontal elevation as theta, and so that this length become simple L divided by 2 cos theta. And the moment forms by the weight of the rod become negative. Again I need this perpendicular distance. Now here we know that actually the center of gravity of this uniform rod exists at a distance L, capital L divided by 2 from point A. That means this distance become L divided capital L divided by 2. And here so that this distance become capital L divided by 2 cos theta. You have to be careful when you are finding the lengths here. Here capital L divided by 2 cos theta. Since this one is in equilibrium, you know that actually the net moment or the total summation of the moments around this point should be equal to 0. Now here you can cancel here the fraction half and also cos theta. You will take UL equals MGL. This one is the relation. Now here I am trying to take the upthrust on the rod. You know that here the immersion part has a length simple L. Now here I am taking that the cross-sectional area of this rod as uniform, and so that I can apply the length L instead of the immersion volume. L into rho WG into L equals, here I need the mass of this rod. Mass is taken by density into volume. Since the cross section is uniform, I am applying its total length instead of the mass, capital L. Here G into L. You have to be careful when you are writing expressions. Here don't forget that since the cross section is uniform, I have taken the length instead of the volume. And so that here G will cancel and you will take rho W L squared become equal to rho capital L squared. Now rho divided by rho W become equal to simple L divided by capital L squared. That's why here I took, if this fraction become half, then I have to take the square of this half. That means it become 1/4. If this fraction become 2/3, then take the square of 2/3. It become 4 divided by 9. If the fraction become 3/4, I am having the relative density of the rod dash 9 divided by 16. I have mentioned them earlier. Now this one is a very easy method that you can apply to find the relative density for a given substance. Normally, when you are facing MCQs, clearly you can minimize the solving time for a problem if you know a such method. Don't forget, if the object floats freely, then the fraction of the immersion part in water gives the relative density, but in a such situation when this object floats with a support of the vertical wall of the container, clearly you have to take the square of the fraction and you will have the relative density for the substance. And this one becomes a perfect method to find the relative density very easily. And so that I think this one become very valuable for you because I have mentioned all the methods here. Actually there are different methods to find specific gravities, but here I gave you a major and special method that you have to use if you need to take the answer instantly. Right, okay? And I will give another short methods under different parts in physics, and you can see them in my next video.